The lakes forming on the surface of Greenland are storing a large amount of meltwater throughout the season. Sometimes you see really shallow, kind of lagoon, almost snow swamp sort of things, all the way up to lakes that are almost 30 feet in depth. As a glaciologist, I'm looking at this and I see bright ice, some darker ice that happens to have more dust in it. I see really bright snow. I see the lakes. You can see kind of a network structure where they're draining together. So intuitively, we look at this beautiful blue color, and you know that the darker the blue, the deeper the lake, which is nice, but we want to be able to quantify that. So imagine that you're a little beam of light, you get emitted by the sun, you hit the surface of the lake. As the light goes through the lake, some of it is absorbed by the water, and a little bit of it gets scattered back. Then the light hits the bottom of the lake, and a bunch gets returned, reflected, goes back through the column of water in the lake, and that's what Landsat can see. So we need to be able to understand how much energy is being absorbed by the water, what the reflectance of the bottom of the lake is, and what proportion of light is being scattered back by the water. Once we have those three pieces of information and what the brightness that particular pixel is, then we can say how deep the water is in the lake there. These lakes are darker than the ice around them, so they're going to start absorbing more energy from the sun and melt more. A little bit of melt concentrates in one place and then melts more, which melts more, and it's a feedback mechanism. And when the lakes get big enough, they can force open fractures that then drill all the way down to the bed of the glacier, transporting this water to the base where it can temporarily speed up the flow of the ice. And so we're interested in the lakes because they might be important for speeding up the ice sheet.